This video tutorial looks at the mathematical strand of data representation and interpretation. And more specifically, we're going to focus on looking at some data types and data displays. Now, the first type of data that we're going to look at is called categorical data. Now, obviously, this is any type of data that can be put into categories, and I've got some examples here on the screen. So the types of ice creams, favorite sports teams, or pets. You may be looking at those different things. But basically, categorical data is anything that has a word associated to it or can be put into a group or a category. Some good options for displaying categorical data would be column graphs, bar graphs, and pie charts. And the reason for this is because these types of graphs allow you to put categories on at least one of the types of axes in the column or bar graph, and the pie chart, you can actually label the different sections of the pie chart with categories if you need to. So these three examples are some really good ways that you can display categorical data. So here's an example of categorical data, and you can see here that we have our categories. So we've got our wins, our draws, and our losses. And then, so that's in our tally frequency chart. And then you can also see that then that transfers across to our column graph, where we have our wins, our losses, and our draws. Okay, so we're able to use those categories to then produce a column graph with those categories to identify which bar represents which category. Okay, so numerical data is the second type of data we're going to be looking at, and obviously this differs from categorical data, being that categorical data is words or categories, and numerical data is in number form. So you might be talking about the number of points in a game, or the age of students in a class, or the size of a shoe of students in a class. These are all numbers, or can all be collected, or the data can be collected in number form. So that's why we call these examples of numerical data. So some examples of how to display numerical data might be in a column graph, where on both set of axes we have numbers instead of categories. In what's called a dot plot, it's basically using a number line to identify how often something happens, and what's called a stem and leaf plot, okay, where you have a lot of numbers. The stem represents the tens of a number, and the leaf represents the units of a number. So we're going to have a look at a stem and leaf plot, and we're going to make sure that you understand this is called an ordered stem and leaf plot. Now, stem and leaf plots can be put in when the numbers are a little bit more random. They're still in their tens, but we need to make sure that in the leaf section, so you can see here that we have a stem section and a leaf section. We need to make sure that that leaf section has numbers that are in numerical order, okay, going from smallest to biggest. So let's just look at a bit of an example here. We're going to look at the Boston Celtics, and this is 10 scores, I think, or it might be 11 scores from one of their seasons recently. And I've already managed to put these numbers in numerical order from smallest to biggest. So the stem that we've got actually starts from 7, because we have a number in the 70s, and that's our smallest number. Then we have numbers in the 80s, we've got some in the 90s. We don't have any in between 100 and 110, but we still need to put it in. Then we have one number between 110 and 120, and then we have 120 by itself. So we would go 7 and 7. Now that represents our 77, because the stem, remember, is the tens and the leaf is the units. Then we have 83, 87, 88, 88. We have 91, 96, 97, 98. We have none between 100 and 110, but we do have 111, and we do have 120. Now you'll notice that in this section here, the tens actually go with each of the units. So we only ever write the unit digit, because the stem represents, or the 8 and the 9 in the stem represent the 8 and the 9 of all of those numbers that we've included. Now let's have a look at an example of a dot plot here. You can see that this is a set of data. So here we've got the set of data of shoe sizes that were recorded for a class. Now what I've done is I've actually pre-ordered them, so I've put them in order. Alright, and that's what you need to make sure you do. And we can see then from our data that the smallest shoe size is in fact 4. The next one is 5. Then we've got 6, 7, 8, and 9. Now, basically all we're going to do is we're going to put a dot for every person that had a shoe size within that range. So there was only one person with a size 4. There are 4 people with size 5, 4 people with size 6, 6 people with size 7, 2 people with size 8, and 2 people with size 9. And that is a representation of our dot plot. One thing you might be asked is to describe a distribution of your data. Okay, and this is really important when we're using obviously column graphs, but we can also do this with dot plots, or we can do it with stem and leaf plots. Now, it's important to know that if most of your numerical data arises in the middle, right, then it's going to be symmetrical. If there's kind of multiple towers in your column graph, or multiple points that come out, then it's going to be bimodal or trimodal. Okay, if it's got 3, so bimodal meaning 2. Okay, if most of your numerical data is towards the end, all right, or the bottom of your stem and leaf plot, or the end, or the right, I should say, then this is going to be negatively skewed. And if most of your data is at the start or the left, all right, then it's going to be positively skewed. All right, so that's important to know. Okay, we also have something called continuous numerical data. Now, continuous numerical data is basically data that's collected that can have many different values. So we display this in intervals, okay, so groupings. And we basically use a frequency histogram, or a kind of frequency column graph, if you will, to show this. But it's really important to make sure that you identify that there's actually no gaps between any of the columns in this particular case. Alright, so you'll notice that a continuous numerical data graph has no gaps between the columns, and that the modal class of this particular graph is the highest frequency, the one with the highest frequency. So this particular one here is our modal class. So here's a good example of continuous numerical data. You can see that the data that's been collected is quite numerous, okay, because we're looking at decimal points here. So what we've essentially done is we've decided to put it into class intervals or groups, and so basically the weight of the pineapples in this particular case would fall within that class interval or that group, and then that would allow us to determine how many there are in each. And obviously the modal class is this one here, okay, modal class, which is between 1 and 2 kilograms. Okay, when we're looking at comparing data, it's a good idea to put the data into a visual before you start trying to calculate any statistics from it. And a couple of examples are our side-to-side column graph, okay, this one here, all right, or a back-to-back bar graph, okay. The one that I really like, gives us a bit more of an idea, is the back-to-back stem and leaf plot. Now we're just going to go through how to construct a back-to-back stem and leaf plot. We're going to compare the Boston Celtics with the Chicago Bulls, and we're going to do our stem to begin with. So we can see that the smallest number here is going to be 7 because we have a number in the 70s, We need to go all the way down to 12 because we have a number in 120s. So Boston is 77. I'll do Boston's first. 83, 87, 88. We've got two 88s. 91. I'll move that one up a little more so we can get it close to the 9. So 91, 96, 97, 98. And then we've got 111 and 120. You'll notice I'm putting commas between my numbers on the leaves. It's really important that we do that. So 80, 82, 86, 87, 95, 95, 96, 96, 97, 104, and then 110. And there you'll be able to compare two different sets of data, all right, back to back, of two different teams. Okay, so here are some practice questions I'd like you to have a go at. Please feel free to pause the video. Once you think you've got the answers correct, continue the video and we'll go through the answers and see how you went. Okay, so the first question said classify the following data as either categorical or numerical and give reasons. Well, it's going to be numerical. And the reason is simple, because the data is in numbers. So therefore it has to be numerical. Okay, so the second question said, place the following set of data on a stem and leaf plot and describe the distribution. So you can see here that we've got our stem and leaf plot. We've put them in order, which is great. And you can see when you turn this on its side, okay, the data is kind of skewed negatively. All right, so the negative side is stretched, which means therefore it must be negatively skewed distribution.